Students, we are given this question, we are expected to integrate this. Now, I would be using the Euler's formula, which states that e power I theta is cos theta positive I sin theta. Okay. Now, if I were to write the real part of e raised to the power I theta, then it would mean on the right side, the value would be cos theta. So this is the formula that we would be applying. So clearly this would imply cos 5x would be nothing but real part of e raised to the power I. In place of theta we got 5x, so place 5x there. So instead of cos 5x, I would be using real part of e raised to the power I 5x. So therefore the integral given e raised to the power 4x times cos 5x times dx is now rewritten as integral e raised to the power 4x times real part of e raised to the power I 5x times dx. Now clearly this is a real quantity, so I can move this real part outside and rewrite this entire quantity as real part of e raised to the power 4x times e raised to the power I times 5x times dx, with the parenthesis being closed. Now I know by formula a power m times a power n is a raised to the power m positive n, and e raised to the power 4x times e raised to the power I times 5x is going to be e raised to the power 4x positive I times 5x. So using these inputs, I would now rewrite the quantity within the integrand or within this parenthesis as e raised to the power 4x positive I times 5x times dx. So close the parenthesis and place the real part there. Now what I need to do is I need to take the x out, so that is going to be e raised to the power x is taken out. I would be getting 4 positive I times 5 times dx, close the parenthesis. So this is basically a constant. Now we know that integral e raised to the power x times dx is e raised to the power x positive arbitrary constant c, and integral e raised to the power 5x times dx is going to be e raised to the power 5x divided by 5 positive arbitrary constant c. So therefore clearly this is going to be real part of, when you integrate this you would get 1 over 4 positive I times 5, that's a constant. Instead of 5 we need to have that constant, times e raised to the power x of 4 positive I 5. Okay, so this is what we have got. I'm not placing the arbitrary constant yet. So now this is equal to, this needs to be the real part. Okay, this has to be real part. So I need to change that quantity into a real quantity. So how am I going to change it? It's simple. Multiply by its conjugate 4 negative I5 and divide by that same quantity, and that would be giving me 4 negative I times 5 divided by 4 squared negative I squared 5 squared, which is equal to 4 negative I5 divided by 16. I squared is negative 1. Okay, so using that negative 1, this is going to be positive 25, and this would give me 41, and in the numerator is going to be 4 negative I5. So you just need to place real part of 4 negative I times 5 divided by 41, and this is e raised to the power, for now let me retain it as it is, e raised to the power x times 4 positive I5. I will rewrite it here. So this is equal to real part of, now 4 negative I5 divided by 41. What I'm going to do, I'm going to write this as 4 over 41 negative I times 5 divided by 41. So this is the way I'm writing it. Now e raised to the power x times 4 positive I5. So that's going to be x times 4, e raised to the power x times 4, times e raised to the power I times 5x. Okay, now this is going to be real part of 4 divided by 41 negative I times 5 divided by 41 times e raised to the power 4x. Now e raised to the power I theta, right? We know that is cos theta positive I times sin theta from Euler. So this is going to be cos 5x positive I times sin 5x. So this is what we got. So close the parenthesis. Now if I were to take the real part, so this is going to be 4 over 41 times e raised to the power 4x times cos 5x. This is one quantity. This quantity multiplied with this would be an imaginary quantity, so that's not going to be of any use to us. But I5 multiplied with I sin 5x with e raised to the power 4x, that would give us a real quantity. So place a negative sign. I squared is negative 1. Okay, place that negative 1, and 5 divided by 41 along with e raised to the power 4x along with sine 5x. Okay, this is what we've got. Now this can be rewritten as, now e raised to the power 4x can be taken out, 41 can be taken out, so we got 4 times cos 5x positive 5 times sine 5x, of course positive arbitrary constancy. So okay, this is the real part. Okay, this completes the solution to the question.